right, let's go through these. For number 1, we had square root of 50 p cubed. Okay, so 5p, is anything missing? Kennedy? Good. Okay, so here, where we had the square root of 50 p cubed, we have 25, 2, 1, 2, 3. Okay, square root of 25 is 5. I have a group of p's. One comes out. Whatever's left over stays inside. Okay, so 5p root 2p. All right, now number 2. Put this on the board. Okay, we could break this up as what are the 2 factors of 200? One being a perfect square. Yeah. 102. 100, 2. Okay, what's the square root of 100? 10. Okay, we have 2 groups of m, so what comes out? M squared. Whatever we can't take out stays inside. So we multiply 2 times n, 2n. So it's 10 m squared root 2n. Okay. Now 3. Okay. We have 28. What are 2 factors of 28? 4 and 7. Okay. Square root of 4 is what? 2. Can't do anything with the square root of 7. So that stays in. 2 goes into 3 how many times? Once. How many are left over? Same thing for y. 2xy root 7xy. Okay, and number 4. 5, sorry. 4 times. Since this is, okay, since you see a fraction over the whole entire thing, 25 over 2, we could break it up. What's the square root of 25? Can we do anything with root 2 right now? That can't simplify, so how do we get rid of it? Yep. Multiply top and bottom by root 2. 4 times 5 root 2 over 2. 20 root 2 over 2, because you multiply 4 times 5. 20 divided by 2 is what? 10 root 2 is your final answer. Yep. No, because this is 4 over 1. Great question. That's 4 over 1. So with fractions, you just multiply across. Okay. Number 8 is correct. Negative 10. Okay. You have the negative on the outside. You could do this a bunch of different ways. Since you're multiplying, this could be written under 1. What is 5 times 20? 100. What is the square root of 100? Or you could have got the same thing with the factor root. And then number 10. Okay. When you distribute, you're multiplying. So we have the square root of 12 plus the square root of 20. We have to break these down. What does the square root of 12 break down into? Yeah, Christopher. 4 and 3, and then what would be your final answer? 2 root 3. How about the square root of 20? What does that break down to? If 2 root 5. This is as far as you could go. You cannot combine those, okay? Because they are different radicals. They are not like terms. So you have 2 root 3 plus 2 root 5. If I had 2 root 3 for this one as well, it would be 4 root 3. Just like if you were to have, can I combine those? No. The only way you can is if they both had x's. That's the same thing with the radicals as well. Okay? So this came up. Will we see operations like this of radicals? No. But it's also good to know that when you're adding or subtracting, you cannot combine like terms because these are not like radicals. Okay? They have to have the same number inside. Okay? Okay, was there any questions on the homework that you had? Yep. So it will take 5 and 5 on both sides? Correct. Yep. Okay. Turn to page 9. Number 29. Yep. Mhm. What do we have to do in order to solve for x? Emily? Okay. Go ahead. Yeah. Okay. Good. Okay. So for these, for the zero product property, you're solving for x. But since there's an x squared term, you have to set everything equal to 0 in order to either A, factor, or use the quadratic formula. Okay? That's how you solve for x. What I did was when I was looking at the key, I thought the dot, so I thought it was negative 100. Okay. It's okay. It's okay. It's good to clarify, right? That's good. Any others? Okay. So 29 is very similar to what we just saw. Okay? I want you to try number 29. Okay? What we just did. Okay, number 29. When you multiply, you have square root of 18v plus 30v. Can I simplify it all? To what? Okay. What do we got? Perfect. 3 root 2v. Can 30 be broken up at all? Nope. How many of you did get that? Good, you guys. Awesome. All right. So, one other piece. What can we, I know it's a little hard to see. This is 4 divided by 3 minus root 6. What's one rule? What can we not have, Porter? Square root on the bottom. So, since this is different, right? It's not like 4 over root 3, right? We could multiply top and bottom by root 3. This is different because we have 3 minus root 6. Okay? How would we go about getting rid of that radical? Yeah, Everett? Okay, the difference here is we have a subtraction sign, right? So we have an expression in the denominator. So in order to get rid of it, we have to multiply by something called the conjugate. Okay? When we multiply by the conjugate, you're going to see what happens. So the conjugate simply means the opposite middle sign. Okay? So we are multiplying top and bottom. Three plus root 6. Okay? So see the difference. Instead of the subtraction sign, we now have a plus sign. Okay? So what this looks like all together, because we're multiplying, we have 4, 3 plus root 6, and then our denominator, this is what it looks like all together as one fraction. Okay? So what do you do in the numerator? What do you do here? 4 times 3 plus root 6. What do we do there? Everett. Distribute. So we have 12 plus 4 root 6. That's our numerator right now. And it's not root 24 because 4 does not have a radical. Okay? So in the denominator, you have two binomials there, which are two terms. What do we have to do? Four-letter acronym, if we know that. FOIL. Okay? So 3 times 3 is what? 9. Good. 3 times root 6. Negative root 6 times 3. Negative 3 root 6. And then what's negative root 6 times positive root 6? No, you're multiplying. Negative root 6 times positive root 6. Would be negative 6, because it's negative square root of 36, which is just 6. Okay? So our numerator stays the same. What do you notice in the denominator? Awesome. These cancel out. So you're left with 9 minus 6. That would be your final answer. Okay? So when you have an expression in the denominator, 3 minus some radical, you are multiplying top and bottom by the conjugate, which is the opposite. So multiplying top and bottom by 3 plus root 6, you distribute, you FOIL. The idea of FOILing is eliminates those middle two terms. Combine like terms, and you end up with 9 minus 6, which is 3. Now, some of you might see 12 divided by 3 and do 4. The only way you could simplify is if 3 goes into both 12 and 4 evenly. Okay? We're going to do another one. I crossed out number 41, but that's the one I want you guys to actually do. Try 41. Okay, follow the steps that are here. Okay. So we have 35 minus 5 root 5. Then 49, we know the middle cancels out, so you really just have to do 7 times 7 to give you 49. Then root 5 times negative root 5 negative 5. How many of you did get that for your final answer? Okay, some of you I saw leave the numerator as is, like this. You want to distribute all the way through. Okay, so you end up here with 35 minus 5 root 5 over 44. Okay, any questions? Okay, Roy? Because you're multiplying top and bottom by negative. 7 minus 5. So 5 times 7, 35. 5 times negative root 5, it's negative 5 root 5. Okay? All right? So that is the conjugate in terms of dividing. We have seen a lot by rationalizing the denominator. Okay? We have seen those. Okay? With the conjugate is when you have an expression in the denominator and you need to get rid of it. Okay? Are there any questions regarding this? Okay. So the next topic we're going to introduce, okay, because they go hand in hand with simplifying radicals. And now, how many of you, when you got a negative inside a square root, you would automatically say what? So if you ended up with the square root of negative 3, what would you say? Typically, yeah. It's not a real number. It's not a real solution. You would say no solution, right? Today, we are actually going to look at why it's called not a real solution, okay? This is called a complex number, which is also called imaginary, okay? Where you can actually solve for a negative inside a square root, but you won't see it on the graph, okay? Because it's imaginary, okay? Complex numbers come in pairs. They always have plus or minus attached to them, when we're solving especially. So, we use this term of the imaginary unit, I. Okay, it looks like that. Okay, cursive I. All right. The I represents the square root of negative 1. So if you see a negative automatically in the square root, you pull the I out. Okay? So this first example shows you if I have the square root of negative 5, automatically the I comes out and I'm left with the positive square root. Okay? If you were to get I squared, that's simply stating square root of negative 1 times square root of negative 1. When you multiply a radical by itself, what do you end up getting? The number inside, correct? Okay? So you end up with negative 1. That's the same thing as saying I times I is I squared, which is negative 1. This little circle that we're getting to is imperative that you know. Okay? If you have, and I know it's hard to see, I to the 0. Okay, if you can't really see it, color it in. Okay, this is I to the 0. Anything to the 0 exponent is 1. Anything to the 0 exponent is 1. So I to the 0. Then if we move to the right, I to the first is just I. Okay? I squared is negative 1. I cubed is negative I. Then it repeats the process. Okay? So how we get to I squared is I actually showed you already. Square root of negative 1, square root of negative 1 is just negative 1. Okay? When you do I cubed, it's I squared times the square root of negative 1. okay, which is just I. What does I squared represent? What does I squared equal? -1. And what is the square root of -1? What's that letter? I. That's how you get -I. Okay? Then, if you have I to the 4th, what does I squared equal? -1. What's -1 times -1? -1 times -1? 1. Okay? So, you might be given I with a specific exponent. What we do to find what it's equivalent to, it's going to be one of 4 of these. It's either going to be I to the 0, I to the 1st, I squared, I cubed, okay? How we get there is divide the exponent by 4. And the remainder is either going to be no remainder, 1 remainder, 2 remainder, 3 remainder. The remainder is going to tell you which one it's equivalent to. Okay? Your remainder will either be you have nothing left over, 1 left over, 2 left over, 3 left over. And then it repeats the cycle. Okay? So here's an example. I to the 5th. 5 divided by 4 goes in how many times? Once. How many are left over? 1. So I to the 5th is equivalent to I to the 1st, which is just what? Look at the circle. Just I. So your exponent can change. Now, I to the 6th. 4 goes into 6 how many times? Once. How many are left over? 2. So I to the 6th is equivalent to I squared, which is what? -1. Okay? Because it has to be one of these. 0, 1, 2, or 3. Has to fall back to one of these. So I to the 6th is the same thing as I squared, meaning it equals -1. Yeah, Everett? Yep. Which is what? So right now, thank you. Right now, the reason I'm telling you what it's equivalent to, so you could see it's one of the circles. Do you have to write these every time? No, you just write 1, I, -I, or +1. That's it. Okay? So for example, 4 goes into 8 how many times? Anything left over. So out of these, what does it equal? 1. There's nothing left over. So it's equivalent to I to the 0, which is 1. How about 9? 4 goes into 9 how many times? Twice. How many are left over? So out of those numbers, 1, I, -1 or -I, what is it equivalent to? Yep. Okay. So I want you to try a few. I to the 52nd. I to the 63rd. And I to the 16th. Okay, try those 3. And you could just, all right, I to the 52nd. What is that equivalent to? Either 1, I, -1, -I. Everett. 1. Okay, because 4 goes into 52 evenly. Yes. Okay. I to the 63rd. Go ahead, Hannah. -I. Excellent. Good. And then I to the 16th. Nick. 1. Good. So the whole idea here is divide that exponent by 4. Your remainder is either going to be 0, 1, 2, 3, and then it will repeat it again. Okay? So that circle is definitely what we need to remember. Okay? But the biggest takeaway for these two, the two important ones that we have to remember is I squared is -1. And if you see a negative inside a radical, it's automatically an I that comes out, okay? Which we're going to look at right now. Bless you. So if we look at A, we have the square root of -3. Typically, when you would see that, you'd be like, no solution, right? And now, this breaks up into square root of -1, square root of 3. What is the square root of -1? I. So you're left with I root 3. Okay? Most importantly, if you see a negative, take an I out. You see a negative, take an I out. Okay? So for example, in B, see a negative, automatically what comes out? An I. Now, how can I simplify the square root of 18? Careful. 9 and 2, which would be, Tyler? Huh? Now, I squared, be careful, careful. So you have the square root of 18, which is 9 and 2, like Everett said. What can we do from there? 3I root 2. The I acts like a variable. Okay? So the square root of 18 is square root of 9 times square root of 2, which is we get 3I root 2. Okay? How about C? See a negative inside. Automatically what comes out? I. Now you're back to your simplifying, what we just did. How do I simplify the square root of 32? What is it? Good. 4I root 2. Because the square root of 16 times square root of 2. Okay. What do you notice in D? Okay. Yeah. There's two i's because there's an I already on the outside, and then we notice it is a perfect square. So we have I already on the outside. We have to take out another I because there's a negative inside, right? So what's I times I? Don't evaluate what's I times I. I squared, okay. What is the square root of 49? 7. What does I squared equal? -1. What's 7 times -1? -7. Good. That's your answer. Okay. Try E. You guys are doing great. Amazing, actually. What does I squared equal? Right. You could take care of the I squared, yeah. So I'm glad you actually brought that up because in the end, when you're simplifying and or solving, we should never see I squared anywhere because I squared equals our -1. Okay, great question. So we have I. We already have an I. Take another I out because of negative. Square root of 90. So we have I squared. Square root of 90 is square root of 9 and 10. 3 root 10. Negative 1. How many of you did get negative 3 root 10? Good. Okay, for F, you just have a negative 1 on the outside. That does not change to I. Okay, do we know that? Okay, the negative is just our simple, what we are always used to, negative on the outside. But on the inside, I have a negative, so automatically what comes out? An I, so I have negative I on the outside. How do I simplify the square root of 54? So what would it be? What does it simplify to? 3 square root of 6. 3I root 6. Okay. I want you guys to try G and H. Yeah, Hannah. There's nothing else you could do here. Only if it's a I squared. Only I squared. Only I squared. Try G and H. You guys are doing great. All right, for G, what do we have? Someone I haven't heard from yet. Camilla. Negative 2 root 6. How many of you did get that? Good, you guys. Okay, this is, we have an I, another one comes out, and then square root of 24. So we have I squared. Square root of 24 is 4 and 6. So we have 2 root 6. I squared is the negative 1. Perfect. How about H? What do we have for H? Someone I haven't heard from. Thank you, those of you volunteering. Porter. 11. How many of you did get 11? Okay. So we have negative I already on the outside. Then what do we take out? Again, I. Okay. Here we have negative I squared and the square root of 121. 11. What does I squared equal? Negative 1. So we have negative times a negative. What do we get? Positive times 11. We just get 11. Okay, awesome, you guys. Yes, Hannah.
So when you have a negative I and a positive I, it becomes negative I squared.
Comes negative I squared. Yes. Okay. We're going to try some practice on number 11, page 11. Okay. 1 through 4. If you want to help each other out, you can. Please do so. 6, 8, 10, 12, 14, then 16, 18, and 20. We're going to go through those by the end of class. Okay. So the ones that I have circled up here on page 11 are the ones I want you to try. Yeah, Everett. Yep. Okay. 1 through 4, 6, 8, 10, 12, 14, and then 16, 18, and 20. Okay. I want you guys to try those. We will go